Your FastMCP client needs to authenticate with a remote server while maintaining real-time streaming capabilities. We'll create a streamable HTTP transport connection with custom headers for authentication, showing both basic and secured configurations. The same client interface works whether you're using headers or dedicated auth helpers, keeping your code flexible across different deployment scenarios. From FastMCP client transports, import streamable HTTP transport. Hash basic connection. Transport equals streamable HTTP transport. URL equals https://API. Example, com/MCP. Client equals client, transport. Hash with custom headers for authentication. Transport equals streamable HTTP transport. URL equals https://API. Example, com/MCP. Headers equals authorization, bearer your token here. Xcustom header, value. Client equals client, transport. This demonstrates the transport abstraction pattern, where streamable HTTP transport encapsulates all HTTP communication details behind a clean client interface. The pattern allows identical client code to work with different authentication schemes by configuring either custom headers or dedicated auth objects, while maintaining consistent tool invocation regardless of the underlying transport mechanism. The distinctive aspect is that authentication and connection details are fully configurable at transport initialization, keeping the client code transport agnostic. The pattern works by treating the transport as a configurable adapter between your client and the MCP server. Streamable HTTP transport handles the HTTP streaming protocol, connection management, and request serialization, while authentication is configured either through the headers parameter for custom schemes or through the auth parameter for standardized approaches. The examples show both basic and authenticated connections using the same transport class, with headers carrying the authentication tokens. While production code would typically use async context managers for proper resource handling, the basic initialization shown is valid for demonstration and simple use cases. This approach solves the problem of environment-specific connection logic by consolidating all transport concerns into a single configurable component. The system enables seamless switching between different authentication schemes and server endpoints without modifying client code. Streamable HTTP transport is shown as the primary method for HTTP connections, with custom headers demonstrated as a flexible way to handle authentication. The trade-off is that transport-specific configuration must be handled during initialization, but this keeps the client interface simple and consistent across different deployment scenarios. Let's break it down line by line. From FastMCP client transports, import streamable HTTP transport. Import streamable HTTP transport, the production-ready HTTP transport that handles request serialization and real-time response streaming. This implements the transport strategy pattern, where different transports share the same client interface, allowing protocol changes without modifying client code. The code demonstrates two usage patterns: basic connection with just a URL and authenticated connection using custom headers. Both approaches are equally valid in FastMCP, with custom headers providing flexibility for specialized authentication schemes. Hash basic connection. Transport equals streamable HTTP transport. URL equals https://API. Example, com/MCP. Creates a streamable HTTP transport instance, the standard HTTP transport for FastMCP that handles real-time streaming over persistent connections. The URL parameter sets the base API endpoint for all requests through this transport. For authentication, You can either pass headers directly to the transport as shown, or use the client's auth parameter with bearer auth. Both approaches are equally valid in production. While this example omits the async context manager for clarity, production code should always wrap the client in async with to ensure proper connection cleanup. Client equals client, transport. Creates the FastMCP client instance using the pre-configured transport. This follows the transport abstraction pattern where different connection methods share the same client interface. For authentication, both custom headers in the transport, as shown, and the client's auth parameter are equally valid approaches. In production, wrap this in async with client, transport to guarantee proper connection cleanup. Hash with custom headers for authentication. Transport equals StreamableHttpTransport. This instantiates StreamableHttpTransport with custom authentication headers, demonstrating one of two equally valid authentication approaches. The headers parameter accepts a dictionary for any HTTP headers, commonly used for bearer tokens and custom auth schemes. The transport layer abstracts connection details, allowing environment switching without modifying client code. For production use, wrap the client initialization in an async with context manager to ensure proper resource cleanup. URL equals https://API example com/MCP. Specifies the MCP server's base endpoint where all API requests will be routed. This URL serves as the root for authentication, command execution, and streaming operations. In production environments, you'll typically pair this with either the auth parameter using bearer auth or custom headers for token-based authentication. Headers equals. The headers parameter injects custom HTTP headers for authentication and metadata. This is the standard approach when you need to pass bearer tokens, API keys, or custom authentication schemes that aren't covered by the built-in auth parameter. StreamableHttpTransport uses these headers for every request, ensuring consistent authentication without manual header management in each call. For production, always wrap the client in async with to guarantee proper connection cleanup. Authorization. Bearer your token here. This sets the authorization header using the bearer token scheme, a standard HTTP authentication method. StreamableHttpTransport accepts authentication either through custom headers as shown here, or via the dedicated auth parameter in the client constructor. The custom headers approach provides flexibility for non-standard authentication schemes or when you need to include additional metadata with each request. In production, always wrap the client in an async with context manager to ensure proper connection cleanup. Xcustom header, value. Custom HTTP header for authentication or API-specific metadata. This demonstrates how to pass non-standard auth tokens or custom headers when the API requires them, using the same StreamableHttpTransport shown in the basic connection example. The pattern is consistent with FastMCP's transport strategy. Different authentication methods work through the same client interface. For production, always wrap the client in async with to ensure proper connection handling, though these basic examples omit it for clarity. This closing brace completes the custom headers dictionary for StreamableHttpTransport, the production-ready HTTP transport that handles modern streaming protocols. The headers parameter accepts any HTTP headers needed for authentication or API requirements, with authorization being the most common for bearer tokens. StreamableHttpTransport implements the transport interface that allows switching between different connection methods while maintaining identical client code. For production use, Wrap the client in an async with context manager to ensure proper connection cleanup, though these examples show simplified initialization for clarity. This closing parenthesis completes the StreamableHttp transport initialization with custom authentication headers. The headers dictionary passes credentials directly in the HTTP request, a standard approach for API authentication that works alongside FastMCP's built-in security. For production use, wrap this in an async context manager to ensure proper connection handling. Client equals client, transport. Initializes the FastMCP client using the pre-configured transport. This follows the transport abstraction pattern, where StreamableHttpTransport handles the actual HTTP streaming protocol, while the client interface remains consistent. For authentication, the example demonstrates using custom headers, a fully supported approach equivalent to the auth parameter. In production, wrap this in an async context manager to guarantee proper connection cleanup. Streamable transport configuration. FastMCP's transport system demonstrates a clean separation between connection mechanics and client usage, where StreamableHttpTransport handles both basic and authenticated HTTP streaming through identical client interfaces. The same transport class supports both unauthenticated connections and custom header authentication, with headers passed directly in the constructor rather than through a separate auth parameter. This pattern maintains consistent client code regardless of authentication scheme, though production deployments should use async context managers for proper resource handling.
The header that carries no token authenticates every request